Hi, this is Kath King from Seeking Health, and today I've got the second in my series of presentations about the myths surrounding protein. Today we're exploring myth 2, which is the more protein the better. And this is perhaps the most predominant food fallacy, that a higher protein intake, which is recommended by many in the nutrition and exercise industry, is actually good for us. But protein in excess of our needs is not utilised by the body. And I'd just like to ask you if you've heard of cancer, heart disease, diabetes, osteoporosis, arthritis, Crohn's disease, and hypothyroidism. And I'd also like to ask you if you've heard of something called kwashiorkor. Well, the first is a list of conditions that are related to too much protein. And kwashiorkor is the closest I can come to a disease or condition related to too little protein. But in fact, kwashiorkor is actually a condition referring to general malnutrition from too few calories, and it's seen in starving people in Africa. And I'd really bet that neither I nor you have ever met anyone with kwashiorkor, but we all know plenty of people with all the other conditions that I mentioned. So how much protein do we need? Obligatory protein is what's required to replace used protein, and this used protein is pooped out, and it has been measured. I'm not quite sure how it's been measured, but it's been measured at between 25 to 30 grams per day, and the recommended daily allowance is 45 to 55 per day, so they're being really quite generous. However, when we look at some indigenous cultures, we find many people are very healthy at far lower levels of protein intake. Some are perfectly healthy on 15 to 20 grams per day, and this is due to the body's ability to recycle protein. So the less protein we consume, the more efficient our bodies become at recycling it. It's a bit like a fountain. A fountain may need 10 litres of water to operate, but you don't need to add 10 litres to the fountain every day because it's constantly recycling the water. It just needs a small top up to make up for what's lost. So adults who are not growing need very little protein. And our body shows us this in a number of ways. When we look at how our body absorbs minerals, for instance, we see that minerals are really difficult to absorb because our body does nothing to actively help mineral absorption, and the minerals have to compete with receptors on our cells. On the other hand, amino acids get proactively absorbed. So the term is actually adsorption rather than absorption. And your body expends energy in order to adsorb them because our body expects them to be very scarce. When we were evolving, we ate very few amino acids, so our body needed to ensure that we utilized every single amino acid. And this is, I suppose, nature is telling us that it expects minerals to be abundant, so we don't need to worry about absorption, and it expects amino acids to be scarce, and so we need to make every amino acid count. And how much protein are we eating? Remember that the recommended daily allowance is 45 to 55 grams. The obligatory protein amount is between 25 and 30 grams, but with efficient recycling we may only need between 15 and 20 grams. The average Kiwi gets over 105 grams of protein a day. The average vegetarian gets between 90 and 100 grams of protein a day. The average vegan gets between 60 and 70 grams of protein a day. And someone who's doing an 80-10-10 lifestyle, high carb vegan like me, I've measured my personal protein intake using something called chronogram. chronometer, and you can use that as well. It's an online tool, and I measure most of the time I get over 50 grams of protein per day. So people are definitely consuming too much protein, and there are some serious problems with eating too much protein. And I've chosen 3 that are the most serious, but there are actually many, many more. So first of all, when it comes to liver and kidney damage, we really need to review what we talked about in the last video about the chemical composition of carbohydrates, protein and fat. So you can see that both carbs and fat are made up of carbon, hydrogen and oxygen, but protein also has nitrogen, and that causes a waste disposal problem for our body. Because we have no room to store amino acids and they can't be used for fuel as they are, our body needs to get rid of the nitrogen, and that causes our liver and kidneys to work overtime. Once it's gotten rid of the nitrogen, then it can actually be burned as fuel or stored as fat. But sitting as it is as protein, our body can't do anything with it. And this is the cycle our body uses to deal with nitrogen. So nitrogen quickly becomes ammonia, which is really harmful to us, and our liver quickly deactivates it by converting it to urea. And then the kidneys convert that into urine. So this whole process is really hard on our kidneys and our liver. There's also a connection between protein and cancer growth. Excess protein makes cancer grow faster, and this is due to protein's role in increasing insulin growth factor 1, IGF-1. And this is an essential hormone that controls cell division and death. It controls metabolism and some other body functions as well. And because of IGF-1's role in controlling cell division and death, it actually stimulates cancer growth. It stimulates those cancer cells to divide, and it also prevents the self-destruction of cancer cells. And the worst animal protein in terms of cancer growth is from milk, and that's because milk actually contains the hormone IGF-1, because it's designed to stimulate the growth of baby calves into cows. And although it's mostly animal protein that's linked to cancer growth, if you're eating highly concentrated plant protein, like isolated soy protein, the type of thing you might find in a protein supplement or a protein shake. So that concentrated plant protein is also connected with cancer, whereas whole plant foods are anti-cancer foods. And thirdly, excess protein causes inflammation. And while acute inflammation is just a natural part of the healing process, and it can be helpful when you cut yourself or you get a cold, when it becomes chronic, it becomes deadly. Inflammation is linked to cardiovascular disease, cancer, arthritis, and autoimmune diseases. Inflammation is part of the immune system. The immune system protects you from threats, and if a threat is detected, it sends in the troops, which entails an inflammation. And the way this connects with protein is that most protein is broken down into individual amino acids, but not 100% of protein is broken down that way. Some protein makes its way into the bloodstream, which then gets targeted by the immune system because it interprets animal protein as a threat. Animal protein could mean things like parasites or microbes. I mentioned at the beginning of this presentation that adults who are not growing require very little protein. So what about growing infants? Human breast milk contains approximately 6% of calories from protein, and this supplies all the protein needs during infancy, which is the time of a human's life when protein needs are the highest. On a diet of 6% protein, an infant will double its weight in 6 months and triple its weight in a year. And so how can an adult who is not building new tissue at the same rate possibly need a higher percentage of protein than this? So it's not the more protein the better. We actually need to be far more concerned with how not to get too much protein. And if this video has been helpful and given you some new insights into protein, please give it a thumbs up. Any questions, just comment below. And don't forget to subscribe to catch the next exciting episode when I'll discuss the myth that plants have no protein. Thanks for watching.